And we're live. Hi everyone. Hope the week is going perfect. So we're now on the third webinar of the Serverless Spring Hackathon 2025. Hope everyone is doing great. We'll be monitoring the chat during this live stream, so feel free to mention if there is any question or anything you'd like us to discuss. We'll have two different parts for the webinar today. I'll do a little introduction or just a few reminders. And after that, we'll go straight into the actual talk. So what everyone is here for. And hi, Wolf Tomato. I've seen you joined most of the, or all of the webinars so far. I'm happy to have you here again. So as mentioned, I'll start by providing a quick recap of what the hackathon actually is. A reminder of the challenge is all participants will need to deliver a full stack Spring-themed event-driven application. And also important, using Momento Cache or Momento Topics or bonus points for whoever use both. The idea is for you to learn and work on an event-driven architecture and also learn how to use now to implement Momento services. As a timeline, we had last week Paul here on screen mentioning what we already had done and what other webinars were still on board or waiting for us. We already did the kickoff with the event-driven architecture introduction by Rejoice. Then with a really good talk by Alessandro for a real-life implementation of event-driven architectures. And today, another really important topic, which would be observability in event-driven architectures. Next Friday on May 16th, we'll have the last webinar before the submissions close, where we'll have Alan on screen showcasing an application and also some best practices implementing Momento Cache and topics. After that, we have the submissions. We've had some questions on Discord on when the submissions will open and how everyone will need to submit their projects. We're working on opening the submissions form early next week. We'll let everyone know via Discord and also via email once they are open. And I'll mention right after that a quick reminder of what everyone needs to submit. On the week of June 2nd, we'll reach out to the winners to let them know that they've actually won or that their application has won, and giving the details for them to also join June 6th. June 6th, we'll have our banger panel of AWS Hero judges. They will go over the applications that won, why they were selected, and some comments on the actual event-driven architecture showcase or how it's currently going. For the project submissions, early next week, we'll open the form, letting everyone know via email and also via Discord. A reminder, submissions will close May 18th, 11:59 p.m. Pacific time. Let's make sure the time zones doesn't play a bad. So Pacific time, 11:59 p.m. We will need or we will expect all participants to deliver an article. A part of the article will also need a demo video up to 5 minutes of you explaining what your application does, how it was built, and the most relevant aspects you want to mention. And last but not least, the actual repository to GitHub so that we can evaluate the code. We'll expect 3 links. The 3 links have to be publicly accessible, meaning that no login has to be required from our side. Otherwise, we won't be able to analyze the different submissions. As a quick reminder, we are on the Belief in Serverless Discord server. Feel free to join in case you have any questions or want to discuss anything regarding the submissions or the hackathon itself. A few frequently asked questions that we've seen on the Discord channel, a part of how to submit and when to submit, are most people asking and working together on Momento, how to implement Momento into their applications. A quick reminder is that some candidates are mentioning most of the logic being done on the front end. Please remember the front end application is visible to everyone. Everyone can inspect the web browser and see the code and mess around with the code. So make sure to implement validations and most of your logic on the backend side. We also had another question mentioning on how the video has to be recorded, if it was good or okay to have it recorded on localhost, or the expectation was to see it live already deployed. Ideally, it should be already deployed, but it's also okay if it's on localhost. But if two applications have the same level, one is deployed, the other not, we'll probably go with the one that was deployed. So if it's possible, deploy the application and just record it there. Once you have recorded, you can close or remove all the services that you were using so that it doesn't get exploited. So after this quick introduction, and now that we've seen that some people also have started joining, let's go to the actual part where we will introduce Zach. Hey, Zach, how are you? I'm not able to hear you. Let's see in the comments if everyone is able to hear. I know we had a similar issue on the first one where Jonathan wasn't able to hear me. So let's see. Nothing yet. We have also Paul on the back end, so if he's able to hear them. Okay, Daryl also confirms that there's no audio. That's the things of going live. Everything breaks when it's less expected. Let's give it a second. We were able to hear him a few seconds ago, so let's see if we can quickly fix it. Let's see. Still pending, no audio. Let's see, because there's a backend. Paul is able to hear him. Let's see, Paul, if I go out of the screen, will we hear Zach? Okay, let's give it a second for Zach to rejoin so that we can go ahead with his presentation. I'm also seeing some comments of people joining and also mentioning that there's issues with audio. Let's see.
Yep. Am I back with my audio?
Perfect. I'm able to hear you now. That's
Awesome.
things of going live.
Yeah, always happens when we are live.
Exactly. Everything works until you press go live.
Yes. And my screen is up.
Okay.
Awesome.
Perfect. So now we also have confirmation from the audience. Daryl and Buff Tomato mentioned that everything is good. We're okay to continue. So thanks again, Zach, for joining us today. I'm really excited to have you here, and I leave it up to you to go ahead and remind everyone why observability is so important.
Thanks, Lorenzo. Yes, observability is important. Irrespective of how much we tested it backstage, we were not able to hear me. So, yeah, observability in production is very important. And today we'll talk a lot about observability and why it really matters in event-driven architectures. And uh, during this webinar, we will go through the different pillars of observability as well. So if you have any questions, post them in the chat and I'll try to answer them. A quick introduction of who I am. I'm Zachariah Noel. I am a senior developer relations engineer at New Relic, a serverless hero. I also write a lot of content around serverless, be it on my newsletter or blog called the Serverless Terminal. And I also run a podcast with a hero called The Zach Show Talking AWS. So you can use a QR code to connect with me on socials. I'm mostly active on LinkedIn. So if you have any questions outside of today, you can hit me on your LinkedIn. So today we will learn a little about event-driven architecture, just to set the context, because I know that the previous sessions did talk a lot about event-driven architectures, the different kinds of event-driven architectures, and events and everything else, but we'll focus on specific services that event-driven architectures are offered in the AWS serverless stack. We'll also look at the challenges that we have for observability and the different pillars of observability available. And we'll wrap it up with some best practices. Like Dr. Werner Vogels mentioned in his reInvent keynote 2022, the world is asynchronous. Yes, the world is asynchronous because you make API calls, you request things asynchronously, and you don't really wait for it to happen. Exactly what event-driven architecture also is, because as an event happens, it just triggers, be it Lambda functions, be it step functions, whatnot, and it carries on. It doesn't really wait for the event or the execution of this event triggered to be completed, and you're not stuck in a loop, or you're not stuck waiting for a response. So the world is asynchronous, as well as we'll be talking about event-driven architecture. So we'll understand how asynchronous world and event-driven architectures come into play. Like I was talking about the different, I'll be touching upon the different AWS services that are in play with EDA. In AWS serverless stack, it would be SNS, SQS, and EventBridge. So if somebody of you who are not familiar with SNS, SQS, EventBridge, SNS is a simple notification service. It's basically a pub-sub kind of a service where you subscribe to a topic, and the publisher, whenever they publish to a topic, the consumer receives it. SQS is basically a queue system where you could have it either as a FIFO queue or a standard queue. Whenever you send messages to the queue, it is being sent or delivered to the destination. Similarly, EventBridge is a bus or a pipe where EventBridge helps you with redirecting events from a source to a destination. You could have a lot of capabilities with respect to filtering, or even having different kinds of rules in place telling that what kind of events are to be routed to the destinations of AWS services or API endpoints, whatnot. So today, when you're trying to build event-driven architectures, one of these three, or any of these three, or all of these three come into play for your typical architectures. Yes, you may not use all of them. You may use only one or all of them. Also, it's completely based on what you're trying to build and what you're trying to achieve. So choosing the best architecture for the day or for the need is really important, and choosing one which really plays around for your event-driven architectures is also important, because all these services have pros and cons. And I did have a blog about comparing all of them earlier on, and I'll drop the link in the chat sometime. So you can take a look about how do you choose between these services and how is it crucial for your event-driven architectures. Since I was talking about these services, I know Lorenzo that Sandro did talk a lot about EventBridge, and I'm not going to focus more on EventBridge today, just to balance it out on SQS and SNS. So the microscopic view of different patterns with event-driven architectures would be a service invoking another service. So basically, you would have architectural patterns where an SNS is probably invoking SQS, or SQS is invoking a Lambda function, or Lambda function is invoking either an SNS or SQS. So a typical way where you see a bunch of things in your architecture, and one of these architecture patterns it would be that an AWS service would be invoking another AWS service as and when these events happen. So it could be things as simple as, hey, I am posting some message to my topic, and the topic delivers it to the subscriber. Similarly, as and when things happen in the topic or in the queue, it triggers the destination Lambda function, or it could even be another topic, or it could be another SQS queue itself. So basically, what you'll try to do is build that service to service integrations, be it as publisher subscribe patterns or the queuing patterns that you have with serverless. Now, let's just take a bird's eye view of a really complex architecture. So this is something that I was trying to cook up when you have a real world scenario where a person uploads an image to an S3 bucket, and the S3 bucket has the put object event being pushed to your event bus, and the event bus ultimately routes it to a right destination, be it Lambda function or step function or whatnot. Similarly, there would be scenarios where you would be integrating them with an API interface, something like AppSync or API gateway, that invokes a Lambda function that can in turn call SQS, SNS, and there's a whole flow going around based on what your use case is. So there could also be patterns where a Lambda function is invoking another Lambda function. Or there could be scenarios where you have a DynamoDB table, and as and when there's a change in DynamoDB, you could use DynamoDB streams, and the streams could invoke a Lambda function, or it could even be sent to EventBridge, and EventBridge could then route it to the needed destination. So as complex can it get? This is something that could be in a real world scenario. You could think it's chaotic, but in when you're trying to build systems for things such as e-commerce websites, or it could even be things such as food ordering apps, or anything such where you require a payment module, you might require a ordering module, or anything such that depends on an external system as well. Be it for payments, it could be a Stripes. So you will have endpoints which are integrated from your Lambda function, invoking payment gateway, and you would have to wait for the payment gateway. And you would probably have the payment gateway integrated into your system either with webhooks, or you would even have something called as SaaS event buses, because there are ISV partners of AWS who support SaaS event buses, and as and when events from those buses happen, it invokes the event bridge bus, and then the bus takes on its course of action with the rules defined in it. So you could again take Stripe, integrate it into a event bridge with SaaS event bus, and once it completes, again, event bridge will route it to a Lambda function. So as chaotic as it could be in production, this is one of those architectures. And for me, it's right now Friday night, and if I'm a person who built this, and I would be like, okay, let me go in and chill on my Friday evening or Friday time, looking at let me grab a beer, or let me just chill on my couch, and I'd be chilling with my beer, but suddenly there's an influx of notifications hitting my inbox. These could be things such as PagerDuty alerts, or it could be Slack notifications or emails or whatnot. So there could be scenarios where in a real life production system, there could be engineers who have configured different alerts, and these alerts could go in out as and when things go wrong in your system. And it could be any day, like a Friday evening or Friday night. And once you see these alerts, these could just say that, hey, something went wrong in your Lambda function. They could even specify a Lambda function, or based on how you design your alert, that will have the contextual informations. But the best practice would be to having it as detailed as possible to start your investigation and start debugging your Lambda function, or start debugging your event-driven architecture. So as As soon as I get this notification, I try to see, okay, hey, something has gone wrong in my production system. I need to debug, and then I realize that, whoa, the even though the alert says something went wrong with my Lambda function, I know for a fact that this picture pops into my head telling that, oh my God, these many Lambda functions are in my application stack. And God save me, because I'm going to have to sit and debug these Lambda functions to find out which one errored, what's wrong, and try to get the root of it, fix the issue, and push it to production, because probably something has broken the complete flow and I have my customers impacted, and it's a it's a P0 item for me to fix this ASAP. So I try to identify, but then yes, so many Lambda functions. But although if I have my alerts uh, uh, structured in a way which gives me more context to where to begin, or where did this error happen, I could identify, oh, this happened in a specific Lambda function, and I could go to that specific Lambda function's logs, or look at the metrics, look at, hey, are there number of error rates that's happened, or I identify the best way to do it would be, you could switch to Lambda function console, go to that Lambda function. There's CloudWatch alerts, and there's CloudWatch logs that's available, the CloudWatch monitoring metrics also that's available on Lambda console. You could take a look at it and understand if the number of errors is high, what's really happening, what are those logs that's coming out, that's giving you information about the error, and then start your debug process. I understood that looking at the logs that, hey, this event bridge is sending in a specific event payload, and that is causing my Lambda function to error up. So I understood, oh, this is from an event bridge. And to look into why that event came in, I need to have the event metadata. So when you're trying to build event-driven architectures, it's also important for you to have metadata or contextual information about what kind of event it is, what is the source of this event. So all of these metadata help you to identify from where did this source of error happen. So from Event Bridge, I understand that, okay, this was an event that came in because I had a DynamoDB item that's been updated, and Streams just sent it to my Event Bridge itself, and Event Bridge then sent it to my Lambda functions. So after a while of debugging, okay, I'll have to look into my database. It's a data related issue. So I need to understand, okay, is there ways that I'll have to handle this data, or what caused this data issue? It could be things that you're trying to create as tags or different kinds of values that you generate out of your own business logic, or it could even be data that's coming in right from the front end, or it could even be data that's being generated on your own Lambda function. So you need to first identify, okay, if this value is coming in from a Lambda function or from a business generated way, or is it coming in as an input? After taking a look at logs, I understand that, yeah, this is coming in from, it takes a while to identify where this is happening. So I'll end up like these Scooby-Doo folks who are trying to look into logs, into different Lambda functions, into different services, toggling between different log groups, identifying which log is this, and even with things such as Xarray, that is with tracing, you try to identify which service was this and navigate the whole process, but it is time consuming and you'll be lost searching for the error that you have to fix. Finally, I understood that, yes, it is the Lambda function. So while I was trying to do it, if you noticed from the previous slides that I'm showing, I jumped from my erroring Lambda function to Event Bridge to DynamoDB table then to my Lambda function. So I had to hop on from one service to another, and I just ended up like Homer Simpson, just rotating around and looking at different logs and traces, trying to understand what is going wrong. So this is what looks like in a typical SRE's life or in a typical developer's life when things go wrong in production and you don't have the right observability tools or right observability practices set in place. Uh, the only problem here was that I didn't have things set up the way it has to be set up, and I didn't have my distributed traces on. I didn't have my contextual information about these logs. So it was time consuming for me to look into all of them and identify the root cause. So the challenges that comes with monitoring event-driven architectures is that because it's distributed, because it has multiple services, and not all services are of a single type. So you may have a bunch of Lambda functions, you may have a bunch of SQS queues or SNS topics or event bridge buses. You could even have step functions. A lot of them have add-in complexity because when you try to instrument, when you try to look into the telemetry information about these services, all of them expose or all of them generate telemetry data in a different format. So even though the source of truth is things like CloudWatch or the observability tools, you will end up in a haywire because things are complex. And when things are complex, it also means that you will have a lot of telemetry data. When I say telemetry data, it's basically logs, metrics, traces, events, and all the other metadata information that you get as these services are being executed. So when you have so much of data, it is actually overwhelming for somebody who is trying to look into the errors or trying to understand what these errors are, try to get to the root cause of the error itself. So in a typical event-driven architecture, yes, you would have challenges with respect to identifying what are these traces, which are these traces, which are these logs. And one problem that most of them that I've seen is that they set up alerts, they set up log group monitoring, log insights, all of them, but they don't bring in the contextual information. And when you're trying to debug, contextual information is like gold because that is what helps you to identify what the real cause is or trace to the next one. And there could be scenarios also where once you're tracing, you end up in a roadblock because like I was talking of a scenario where Stripe is invoking my event bridge bus, or it could be webhooks, or it could even be third-party systems that I make HTTP calls to. If that returns an error, it's still a black box. It's still a black box because there's compliance issues. I cannot get what went wrong on a third-party system, and I just see it as an error. So the rest of the systems that's dependent on that piece of information also errors up, or you need to build in error handling mechanisms, retries that is in place, so that you're trying to handle these kind of unknown errors also because it's locked in a black box as well. So you have to be mindful about working with these kind of systems. And with event-driven architectures, what the crucial problem that comes in is because it's distributed, you have to get all of the telemetry data, and looking into it is cumbersome. So now that you get an idea about what is the real issue about using event-driven architectures, and yeah, I hear you as well, Buff Tomato. So yes, it is cumbersome. And now that you have understanding about what are the challenges, here is the pillars of observability. So I was talking about logs, metrics, traces. Yes, these are the pillars of observability because these tell you all of the telemetry information about how your systems are performing in production. And when you get an alert, these are the starting points for you to start debugging and start looking into what really went wrong. So first, let's look at what logs are. Logs are basically structured information that you log as and when any event happens, be it during the execution of your Lambda function to even execution of your step functions, or even as and when certain telemetry data from the AWS services. So AWS services also expose certain telemetry data and logs, which give you information about things like when you have processed a specific Lambda function and it's been invoked, executed, and it's been completed execution. Or it could even be things such as SQS posting things to your Lambda function, the message delivery notifications, and all of these logs, which you can log and have information about it structured in your observability tool. So I just took a screenshot out of your Relic logs, and this could be one such example where you have tons of logs that's been written onto your system, and you need to have the right information about what these logs are. So adding in more metadata information, it could be things such as what the source is, where is this log coming in from, what is this log doing. It's also necessary for you to identify if it is a successful log, or was it an error and you logged it because of an error, so that when you're trying to navigate across different logs, the tools that are there out there will help you to also remove all of the successful logs, focus only on errors, or include only errors. You could do all of the kind of filters with logs to identify and remove the noise that you're looking at while you're trying to identify what was that error. So it's important with observability tools that they remove the noise for you while you can only focus on what is really required. So today you could have logs on your CloudWatch log groups, but I just took a screenshot out of New Relic logs that have been generated as and when the telemetry data has been generated on my AWS workload. The second pillar that you would be working, or that you would be focusing when you talk about observability, okay, I think, Paul, that's for you to change the layout. So the next pillar that we'll be talking about observability is metrics. And metrics are the quantifiable information that you get while the services are being executed, while things are happening in motion. So all of these metrics, it could be things such as the number of messages your queue has been processing, or your topics have been publishing to your subscribers, or even the number of events posted on my EventBridge bus, which could give me information about how many messages or events have been processed. There could also be metrics around the number of failed events or the failed message deliveries that can help me understand, oh yes, in production, while the system was out for 10 minutes, there were about 20 messages that were not delivered, or there could be a lot more in the real world scenario, but just taking some numbers off my mind. But these metrics help you to understand how are they performing in production, and get you the right information about the service state, and also the status about the health of the system. So you could define your own dashboards, and you could even have your own metric set with you could even have your dashboards with the right metric set as per your business requirement. But one such integration that New Relic has with AWS is the SQS integration, where there's a ready-made dashboard available, and you just have to integrate with your AWS account and navigate to the SQS queue that you have, and the dashboard does the rest of the heavy lifting for you to generate it as per the golden signals that we have. So it could be metrics around the number of messages that you've been receiving per second. Also, it could be the things such as the visible message, the delayed message. You could also configure delay messages. So you could have metrics around how many messages have been delayed. If it is a dead letter queue, you could even have information about the dead letter queue. So all of these gives you one look information about how your system is performing. So metrics help you to Metrics really helps somebody who is trying to monitor the system and see if it is working good or not. Some of the metrics could be as the approximate age of the oldest message, to the number of empty receives, the messages deleted, received, sent, and also the size of the messages, because it's also important for for us to be building. When you're building with SQS, you would have to be mindful of the size of the payload. So you may have to chunk certain messages and send it. So sent message sizes also places a good metric for you to understand how your system is performing. One other integration that New Relic has is with SNS topics. And when you integrate them with your AWS account, what it does is that it derives all of the metrics that CloudWatch gives, and also generates the golden signals that is there in context of an SNS topic. Golden signals could be things such as published messages, delivered notifications, and failed notifications. For this, while I was just demoing a specific SQS queue, what did I do is I just started posting messages, and I didn't have a subscriber, so you could see the delivered notifications and failed notifications are still 0, but there's one published message that's there. I see a question around how does New Relic connect with Lambda and AWS service. So just giving you a little brief about AWS integration is supported with our agents, and we do have Lambda function layers available that you can instrument to your Lambda function, and also AWS infrastructure agent that's there. So you could instrument it once with your AWS infra, and all of these metrics for SNS, SQS that I'm showing is with the infrastructure agent. So another pillar that we have with observability is traces. Traces, according to me, is another important aspect after logs, because this helps you to give you that journey or the sequence of these logs and understand about where you have to head next when you're trying to look at a specific log. So the same example, when I go back and talk about jumping around from my Lambda function to event bridge and database, and also back to Lambda function, you could see that I had to do this because once I see the log, I understand, oh, this could be from my this could be from a specific service, and then I go into that and see the execution logs. So traces, what it does is it creates a span of events and span of logs. So it basically groups things across, and you can have a complete navigation from how did that whole event occur and the journey of that event across multiple services, and when it completed or when it errored up, what is the duration that it took, all of those information. So here's another screenshot from New Relic's traces. So you could see that I have an SQS queue, and also I have a Lambda function that's posting into SQS queue. So when it is doing it, what really happens is that from my Lambda function, when I invoke into SQS, I post a message, and SQS in turn will deliver it to a destination. Here in this case, while I was instrumented, my Lambda function was not the destination Lambda function was not instrumented. So you can see that in the destination part of it, it still says unknown. But when you're trying to work with the complete event-driven architecture, it's recommended that you instrument it end-to-end so that you know for a fact what is the complete journey. Along with when you're looking at a trace, it gives you a complete entity map and a service map for you to understand visually what is the flow of events. Along with it, there's also the execution details with spans, available durations, and you can also see the time that it took and the delay that it happened. This gives you the complete overview of how this complete traces. In case if there are different logs that you want to dig into, these traces can also navigate into logs, giving you more contextual information for that specific trace. That helps in identifying the issue even faster. So now with that, when you're trying to build applications, with observability. Now you have a clear understanding about the pillars of observability and what are the touch points when you talk about event-driven architectures. So here are some of the best practices when you're trying to build with EventBridge or SNS or SQS or any such AWS service in general. So you would have to set up certain metadata for your logs so that when you're looking at logs, you know for a fact what is this log about and what should you look at, how should you navigate across. Also, when you're working with different metrics and dashboards, it is important that although you will get ready-made dashboards available, the screenshots that I showed were ready-made dashboards, but you should be able to configure them and work it across based on the metrics that is really important to you, because you as a person who is trying to monitor the application should be able to look at it at one go and understand how it's performing. So configuring the right metrics that you have for the dashboards is also important, because you'll have to look at the right metrics, understand how it's performing. Once you have the dashboard set up, you have the logs set up, you know that there is also distributed tracing that's being done and configured behind the scenes. You need to configure your alerts with context. So whenever you're getting alerts or whenever there's an incident that's getting created, you need to have contextual information of what that alert is, what that incident is, so that you can start your investigation by looking into the right trace, the right logs thereon, and then you can pinpoint the issue easily. So while you're building EDA applications, my advice would be set up metadata for your logs, configure the right metrics, and configure alerts with context. So with that, I hand it over to you, Lorenzo. So thank you.
Thanks a lot, Zach. Thanks everyone for being here for this talk. I really like that, especially the comparison of what happens when a Friday night you get that alert. But I guess it would be even worse getting an email Monday morning from your boss stating, "Why didn't you get any alert on Friday when everything was waiting, was breaking?" So yeah, that's one of the points why observability is that relevant. Here, you mentioned to add metadata to your logs. If there would be one tip regarding that you had to give, what would it be?
So especially when you're trying to work with Lambda functions, or when you're working with traces of Lambda functions along with different AWS services, it's hard to identify that which Lambda function caused it or which alias of a Lambda function caused it. So metadata of these Lambda function names or aliases also is helpful for you to trace back the right way. So yeah. So
no, that's a really great point. I wouldn't have thought of adding the Lambda aliases, since one version could work correctly and another one would break everything, especially if you're doing blue-green deployment. So that's something to to consider. That's a really great tip.
most of the times it'll end up being the latest, but yeah, who knows? There'll be one version that's the culprit.
Exactly. Let's see. Is there any questions from the audience for Zach regarding the presentation, how to implement it? I like the question from Eduardo. There's some misconceptions, or people always think before adding observability because of the cost or because even of the layers. I've also had issues with layers from other providers adding some latency, especially inside VPCs. That's always an issue. Any recommendations of what we would need to look into before implementing or choosing what approach would be best for us?
Yeah, I think with Lambda function, layers is the approach with extensions. And now that uh, init phase is also priced differently, not just the cold start, but it can also become an expensive Lambda function execution. But yeah, I hear the concern, and even with a lot of observability tools out there, that is the concern that we hear from customers who are using it. There are a lot of optimizations that's happening behind the scenes with, of course, all of the observability tools trying to make things more light on the extension side. But the best way to do a Lambda function instrumentation is with extensions.
Perfect. We have the first question here from Buff Tomato. Is for highly coupled event-driven architecture systems, how do you distinguish between issues related to event delivery versus event semantics, and what role does observability play? That's a good one.
Yep. So in terms of event delivery, this is where the metrics come into play, because you get to understand if there was something that has failed, and you get to also know that when did this fail. So then you can look back into your logs about what was the event and into the event semantics. So logs and metrics combination comes into play with decoupled EDA systems related to event delivery and event semantics. Also, what I've seen is that people use really, they've configured a lot of event schemas that is there. That also helps them with respect to, because primarily these data are being shared across multiple AWS services, event semantics, and that following a specific schema across your application or across your org as a practice really plays an important role.
Yep, couldn't agree more with event schemas. There's even a SaaS called Event Catalog, which the point is trying to, or is actually bringing to everyone, which is really good. Not only, or not to observe the actual how everything is working, but to have everything documented so that you know, okay, this event, yeah, that's an issue with the schema, or where the issue might come from. That's also something that might help. Perfect. And we also have that thank you from Bob Tomato. Seems that your answer was just perfect.
Thank you, Buff Tomato.
Okay. Is there, I don't see any other questions coming in. So similar as I asked Rejoice, if you had to give two sentences, what do they really need to remember of your talk, of what do they need to have in mind before or when they're implementing any type of observability into their systems?
Yeah, I think when you're building building EDA with observability, the important aspect is defining those important metadatas and defining the right alerts. Like I was wrapping up my session, I called out 3 takeaways. So I'll probably iterate on the same. Creating the alerts for the with context, and also having the right metrics on your dashboards and more metadata for your logs.
Yeah, couldn't agree more. There's also the other scenario where people add too much metadata or too much information to the logs. So please be mindful of that. Logs are or can be expensive. Just use the bare minimum of what you need to actually understand your services and be able to debug it. But with that being said, thanks again, Zach, for joining us today, bringing observability to the table and to everyone's mind now that they have a little bit more than 1 week to complete this this challenge. A reminder for everyone listening, we are on the Believe in Serverless Discord channel, a server. We have a channel there where you can hop in, ask questions. I know Zach is also inside the Discord server, so maybe you're lucky enough for him answering if you have a specific question for him or regarding observability. So thanks again, Zach. Thanks everyone for joining today.
Thank you, Lorenzo. Thank you, everyone.